5b, the natural exponential function. So today what we're going to do is learn about the natural number e and what its graph looks like. In terms of success criteria, you need to remember the value of e and also apply concepts of the exponential function to the base of the number e. So what on earth is e? Well, it's just a number that has been defined using a letter, sort of like pi is 3.14. It's a naturally recurring number, pi, when we look at things like circles. So is e. E is Euler's number. It's called the Natural's number, and it appears in many equations in mathematics and physics. So this number seems to keep popping up in things like light waves, sound waves, quantum waves, and just a whole bunch of mathematical definitions. So instead of having to write 2.71828 and it's an irrational number, it goes on forever, we can say that it is the number e. So what you should remember is that it's a number that's between 2 and 3, and I just remember it as 2.7 something. That's generally what I know it as. So what does that look like if we use it as an exponential function? So this is what our base 2 looks like, and you remember how we spoke about the larger the base, the steeper it's going to get. So you can compare 2 as a base compared to 10. Remember, 10 is going to move up a lot faster. So e is just a little bit greater than 2. So it is going to be steeper than 2, but not by too much, because remember, e is 2.7. So that is going to be our new type of exponential, and very often we're just going to be using e. We're very rarely going to be using any other base from now on. In terms of the features, it's all the exact same as all the functions, the exponential function that we've looked at so far. So it crosses the y-axis at 0 and 1 because e to the power of 0 is still 1. We have a horizontal asymptote, which is the x-axis. We've got a domain of r, that range is r plus, and they are all increasing functions, as you can see, unless, of course, we have a reflection. So it's pretty much the same as yesterday's lesson, but all we're going to now do is just apply this to the base of e. So example 6 asks us to state the transformations. So we don't have to graph anything so far, but we just need to state it. So for part A, we can see we've got a 3 out the front and a 2 inside. Out the front means it's a reflection in the x-axis, and in front of the x means it's a reflection in the, a dilation. So the first thing that we can see for graph A is that we've got a dilation of factor 3 from the x-axis. So remember, on the outside it affects the y values, which is why we say from the x. And then the inside, there's a bit of a trick to it, dilation of factor, and you have to flip it 1/2. And if you don't remember why, go back and have a look at mapping from the y-axis. So that's all that's happened here. So we can't really see anything. If we were to graph this, it's just going to look the same as other graphs. So the only things that we can really see with exponentials are reflections and also translations. For part B, we've got a few different ones that have happened. I might start numbering them just to make life a bit easier. So we'll just say this is 1 and 2. 1, 2. Let's call this 1, 2, and 3. So firstly, we're going to have a reflection in the x-axis because it's going to flip all the y values. Secondly, we're going to have a dilation of factor 1/2 from the y-axis because it's going to affect the x values. And finally, we have a translation of 2 units in the negative direction of the y-axis. So that's going to affect our y-asymptote. Our y-asymptote would be at -2. If we look at C, we can see we've got 1, 2, 3. It's going to be very similar to above. Again, so 1, 2, 3. We've got a reflection in the x-axis. This time, so we still have a dilation from the y-axis, but again, because it's flipped, so if we flip 1/2, it becomes 2. So a dilation of factor 2 from the y-axis. And then for part 3, we've got a translation of 2 units in the positive direction this time of the y-axis. And finally, for part D, now this is an interesting one. Remember, what you need to do is if there's any number in front of the x, you must pull out whatever that factor is in order to see the true translation. So here we've got the reflection, where you translate it by 1 to the right and then 1 downwards. So you must pull out anything that you see in front of the x to be able to see that true translation. So I'm going to write them a little bit more in shorthand, but first we've got, reflection in the y-axis. And again, I'm just going to write this shorthand, but we're going to have 1 unit right and 1 unit down. Obviously, this is the proper way to write it, but I just thought we'd go a little bit quicker. So you must pull out any number that's in front of the x, and then when you're describing it without mapping, you will do it in the order of dilations, reflections, and then translations. And that's how you complete this question. All right, example 7. State the transformation required from the graph here to the graph here. Now, of course, you can just sort of have a look at it, but I never really like to risk these kinds of questions, especially when I'm traveling backwards. So we're going to apply concepts of mapping to this. So we're going from the old graph, which is this, to the new graph, which is this. As always, we're going to take everything of y, or everything that is not attached to the x, to the other side. So the first thing I'm going to do is I'm going to add 3, and then I'm going to divide by 2. And then here, that just remains as it is. And then I'm going to equate sides. So y plus 3 on 2 is equal to y dash, and x minus 1 is equal to x dash. And then you need to get y dash and x dash by itself so that you can see what has happened to old x and old y. When we're going backwards, remember, it already happens to us. We don't need to do that. Rearranging step. So we can go ahead and describe it right away. Remember, in terms of the y, you can either describe it as the 3 first, then the 2, or if you want, you can separate it. So it doesn't really matter which way you do it. I might just separate it, but literally makes both answers are correct. In this case, it would be the translation first, then the dilation. Here we have to do dilation, then translation, because it's about what is attached to y. So here they're in brackets, whereas here there's the bracket. All right, I'm going to go ahead and label them. So that's 1, 2, and 3. So first we're going to have a dilation of factor half, and it's affecting y value, so that's going to be from the x-axis. And then 2 is going to be a translation of 3 on 2 units to the it's to the upwards, which doesn't really make sense. So I'm just going to write upwards, or you could say the proper way to say it is in the positive direction of the y-axis, but going for shorthand today. And then translation of 1 unit left. Okay, so that's how you would do it mapping. And I know it takes like 30 seconds longer, but also you can be absolutely assured that this is correct. I just wouldn't risk it. That's all it is. All right, moving on to example 8. Sketch each of the following over the implied domain and state the range. So sketch and then the range. So I just want to label it so I don't forget. I always forget to do the second part of the question. All right, I can go ahead and start sketching from what I know. At some point, I'm probably going to have to find the intercepts though. But it's just a regular exponential function, and we've got 2 translations. So first translation, we are moving to the right by 1, and then the second translation, we are moving down by 2. Again, this is the only one that really matters because it means that our y asymptote is going to be at -2. So there should be a negative there. Once again, we come across the issue of where does it go, here or here, so we should go ahead and find our intercepts at this point. So for the x-intercept, we make y equal to 0. I'm going to take the 2 over, and once again, the way we get e over, if you remember from last year, is by taking the log of that base. If you don't remember, that's totally fine. We will go over it shortly. So that's our x-intercept. It does look like it's going to be a positive number, but just to be absolutely sure, so y-intercept, we're going to make x equals 0. So e 0 minus 1 minus 2. E to the -1 is 1 on e minus 2. So this one also kind of doesn't really help us. But 1 on 2.7 is kind of like a half. The point is it's going to be less than 1. So if we have a number that is less than 1 and then minus 2, that means it's going to be a negative number. So yeah, 1 over 2, which is a half, minus 2 is going to be negative. So a half minus 2 is going to be negative 1.5. So the point is it's a negative number, even if we don't know exactly what that number is. All right, so, and this one is going to be a positive. So log E2 plus 1, 0. And I mean, I can just draw that in, and then wherever it lands will be my y. So that'll be 1 on E minus 2. So that's what the graph looks like. And it's over the implied domain, so it is implied that it's over R. Just one thing that I've noticed is more so because my iPad kind of tries to draw it into a bit more of a curved shape. You need to make sure that your graph actually approaches the asymptote. See here, it's kind of going upwards. You'll actually lose marks for that. So it is a little bit because of my iPad and the curve function that it has on it, but it really should be going downwards like that, and it should connect. So it's just something to be aware of. Just be careful with your sketching. Okay, the last thing we need to do is state the range of this. So the range in terms of the y values, well, the smallest y value I can see is -2, and the largest I can see is infinity. Then we have part B. So similar again, we've got a bunch of transformations that have occurred. Here you want to not fall into the trap of thinking that it's a +3, because again, there's a number in front of the x. So whenever you see that, you must take that out so that you can see the true translation. All right, what has happened here? So there's quite a few things that have happened. You do need to be careful about the brackets. I know that I always say DRT in terms of explaining, but in this case, because there's brackets, you will need to just be careful of that. So one thing you can do to avoid it is to expand the brackets if you'd like to. And in fact, that will help us in finding the asymptote. So let's go ahead and expand it. So that'll be a half E x minus 3 plus 512. Now I can see where my new asymptote is going to be. All right, let's describe what has happened. There's a lot of things that have happened. So dilation, reflection, translations. So the first thing is we've got a dilation of factor 1/2 from the x-axis. It's affecting the y values. Then we're going to have a reflection in the y-axis. And then shorthand, but we're going to move to the right by 3, and we're going to move up by 512. So that means our y asymptote is going to be 512. So that should be quite a bit of information. We're going to go ahead and sketch it. We will need to find our asymptotes, our intercepts in a sec. So y equals 512. And we've got a reflection, so it's initially like this, but a reflection in the y-axis means it's going to do that. So we can draw it in. This is one of those circumstances where we can draw it in before we found our intercept. But, I mean, we've got to find it anyway, so we might as well do it. So in order to find the intercept, we can see that we only have a y-intercept in this case. So y-intercept, make x equal to 0. So y equals half. We'll just go back to the original equation. So 3 minus 0 is just 3. So that'll be a half E3 plus 512. So it's not very helpful, is it? But that is going to be our intercept. So that's just 0. I put our comma. A half E3 plus 512. All right, so that is going to be our graph. What you'd notice is that if you try to find your x-intercept, you'll get to a point where it's undefined. So that's what will happen there. All right, that's it. That's the end of exercise 5B.